Hi everyone, today let's see how to find the eigenvalue and eigenvector of a matrix. So the given matrix is 6 minus 2, 2, minus 2, 3, minus 1, 2, minus 1 and 3. First we will find how to find the eigenvalue. So before finding the eigenvalue, we have to know what is the characteristic equation. So basically for 3 cross 3 matrix, the characteristic equation is lambda cube minus S1 lambda square plus S2 lambda minus S3 is equal to 0. So this is the characteristic equation. How you can remember the formulas? First it will be lambda cube, then lambda square, then lambda, then there will be a constant 1. And here it will be S1, S2, S3 and plus minus plus minus. Okay. So this lambda is nothing but the eigenvalue. And we should know what is meant by S1. S1 is nothing but sum of the diagonals of the matrix, and S2 is nothing but the sum of the minors of the leading diagonal, and S3 is nothing but the determinant of the matrix. So we'll just find one by one. So what is the first one we have to find? That is S1. We have to find S1. We know what is S1. S1 is nothing but the sum of the leading diagonals, that is 6 plus 3 plus 3. So S1 is equal to 12. Then the next one is S2. S2 is nothing but the sum of minors of the leading diagonal. So this is leading diagonal 6, 3, 3. So the first minor of this 6 will be, we have to eliminate the corresponding row and corresponding column. So what we'll be having for the first minor of 6 will be 3, minus 1, minus 1 and 3. So this is for the first leading diagonal element minus. So we have to eliminate this column and this row. So this 3 minus 1 minus 1, 3 will be remaining. And for the second diagonal, so second leading diagonal element is 3. So we have to eliminate this row and second row and second column. So what is remaining? 6, 2, 2 and 3. So I'll just write it as 6, 2, 2 and 3. Now you just try for the third one. Third is 3. So we have to eliminate this column and this row. So what will be remaining is 6, minus 2, minus 2 and 3. So the first one will be, that will be equal to 3 into 3. 3 3s are 9. Minus into minus will become plus. So 9 minus of 1. And the second one will be 6 3s are 18. So 18 minus 2 2s are 4. And the third one, 6 3s are 18. Minus into minus will become plus, 2 2s are 4. So ultimately this will become 8. And this will be 14. And this will be 14. So ultimately 14 plus 14, 28. 28 plus 8 will be 36. So we have also found out what is S2. And the next one we have to find is what is S3. S3 is nothing but the determinant of the matrix. So let's find the determinant. So S3 is nothing but the determinant of the matrix, that is 6, 3, 3 minus 2, minus 2, 2, 2, minus 1, minus 1. So how we have to find the determinant is, first we have to take the first number, that is 6. So let's write down 6. Then we have to eliminate this row and this column, that is first row and first column. So what else is remaining? 3, minus 1, minus 1, and 3. In second, we have to take the second number in the first row, that is minus 2, and we have to change that sign. So it will be minus into minus will be plus. So that is 2. Then what we have to do? We have to eliminate the row corresponding to minus 2, that is first row and second column. So what will be left is minus 2, minus 1, 2 and 3. So minus 2, minus 1, 2 and 3. So let's try for the third one, that is this third 2. So this will be plus 2. We have to eliminate the first row and the third column. So what else is remaining? Minus 2, 3 and 2, minus 1. So minus 2, 3 and 2, minus 1. So that will be equal to 6. 3 3s are 9. Minus into minus will become plus. 1 into 1 is 1. Then we have plus 2. Then minus 6 minus of minus 1 into 2, minus 2, minus into minus will become plus 2, plus 2 into minus will become plus 2, minus 3 2s are 6. So ultimately 8 6 are 48, and this is minus 4. So minus 4 into 2 minus 8, and minus 4 into 2 minus 8. So this will be equal to 48 minus 8, 40 minus 8, that is equal to 32. That is equal to 32. So we know what is S1. S1 is 12, S2 is 36, S3 is 32. So we have to substitute this in our characteristic equation. So let's substitute. So what is the characteristic equation? That is lambda cube minus S1 lambda square. So what is S1? S1 is 12 lambda square plus S2 lambda, that is 36 lambda minus S3. S3 is nothing but 32. That is equal to 0. So now what we can do, with the help of the calculator, go to the function and then go for the equation. Then it will be unknowns 2 or 3, but we have only one unknown, that is lambda. So we have to go to equation. Then it will be asking degree 2 or degree 3. The degree is 3. Then go for the degree 3. Then what you do? Substitute the coefficient. It will be asking A, that is coefficient of first one, that is 1. And then B, coefficient is minus 12. Then C, coefficient is 36. And D, coefficient is minus 32. If you substitute this and if you press equal to, you will get the eigenvalues. So if I substitute everything in the calci, I will be getting eigenvalue that is equal to 2, 2 and 8. Okay, so this is how you find the eigenvalue. But in this case, most probably this will be of some 8 marks or 16 marks in part B. So we can't take any risk. So we have to check at this point. After calculating lambda is equal to 2, 2, 8, we have to check. So how we can check that is, so how we can check this is, we have three eigenvalues, right? 2, 2 and 8. So first what you do, you add all the three That is, we have lambda 1 plus lambda 2 plus lambda 3. So let this be lambda 1, lambda 2 and lambda 3. So what will the sum of this? 8 plus 2, 10. 10 plus 2 is 12. And next what you do lambda 1 into lambda 2 into lambda 3. That is 8 into 2, 16. 16 2s are 32. So this should be equal to sum of the leading diagonals, that is S1, and this will be equal to the determinant, that is S3. Let's see what is our S1 and S3. So S1 is 12, then it's okay, the sum is right, and S3 is 32, it is also right, or product is right. So at this point you have to compulsory do this check whether the sum of the eigenvalues is equal to S1. S1 we know it is nothing but the sum of the leading diagonals, and the product of the eigenvalues will be equal to the determinant of the matrix. So, and in one compulsory 2-mark question, what they will ask us, they will give 2 eigenvalues and tell you to find the third one with the help of this one conditions. So with the help of this condition, we can easily find the third eigen value. And in some cases, what they will do, they will tell you to write any 2 property of matrix. In that you can write this property: the sum of the eigen vectors, the sum of the eigen values will be equal to the, what is S1 is equal to the sum of the leading diagonals of the matrix, that is 1. And the second one is the product of the eigen values will be equal to the, what is S3, determinant of the matrix. Okay, so these are the 2 important questions. So see, for example, if they have given lambda 1 is 2, lambda 2 is 8, and they have given sum of all the eigenvalues, lambda 1 plus lambda 2 plus lambda 3. They will not give like this, they will just mention the sum of the eigenvalues is equal to 12. So find the third eigenvalue. So what we have to do, we can go for this condition, that is sum of the eigenvalues is equal to 12. So we can substitute lambda 1 and lambda 2. It is 2 plus 8 plus lambda 3 is equal to 12. So lambda 3 will be equal to 12. This is 10 coming to this side, so it will be minus. So lambda 3 will be equal to 2. In the same case, they can give the product also. They will give lambda 1 is equal to 2, lambda 2 is equal to 8, and finally what they will do, they will tell that the determinant of the matrix is 32. So if they tell determinant of the matrix is equal to 32, we just know that lambda 1 into lambda 2 into lambda 3 is equal to 32. So this 32 will be equal to 2 into 8 into lambda 3. So we can cancel this. 8 2s are 16, 16 2s are 32. So ultimately lambda 3 will be equal to 2. So this is what, this will be a 2 marks, and in this 16 mark you have to check and get this step. Okay, so that's all for today. Thank you.